Okay, hi everyone. So let's talk about compound interest today and see how it works. Okay, all right. Was not a tongue twister, but my tongue still got tied. But anyways, all right. So here's the compound interest formula: A equals P times 1 plus R over N to the power of N times T. So let's describe what each of them mean. Well, A, that's equal to the amount in the account after T years. Amount in the account after, oh my god. Okay. Account after T years. Alright, so basically that's your, what the equation formulates to. Okay, we want the amount in the account after T years, which sounds like a song, but anyways. Okay, so principal, P, that's what principal stands for. What the P stands for. So this is the principal amount invested. What you start off with, sometimes we can also call that the deposit. Okay, well, 1 is going to stay the same, 1. Now you have R. R represents the annual interest rate, which you will most likely have to change that into a decimal form because you will get the percentage. All right, and then N. Finally, we have N. So this is the number of compounding periods each year. Right, so if it's monthly, then you would probably put 12 compounding periods each year. And, well, T, as we mentioned, is right up here. Okay, I'll go ahead and rewrite it. So T is the number of years that we are using our compound interest formula for. So now let's see it in the context of a word problem. All right, how we can use it. So this is our example. So it says an investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. All right, so I want to find the balance after 8 years, so I'm looking for A. So in this example, we are looking for A, which is what the whole equation equates to. It equals A. So they must have given me everything else. Alright, so let's plug in everything else. So A is what we're looking for, so we can omit that. P, principal, what has been placed in the very beginning, it's $4,000. That's what we started off with. Then we have R, our annual interest rate, which is right here, so that's 5.4%, which change it into a decimal is 0.054. And then I've got N, which is the number of compounding periods each year. Our compounding periods, Texan and me is coming out. Okay, compounded quarterly. Okay, so this means 4 times a year. Quarter comes, you can think of a quarter, the coin, okay? And you need 4 quarters to make $1, okay? I mean, if it makes you happy, think about money, and you can think of quarters, halves, etc. But anyways, all right, N equals, so this is 4 times, so we have 4 compounding periods. Let me keep that in dark, okay? And let's see, we have P, R, N, and then T, number of years. And they tell you the number of years, which is 8. Okay, and then from here you plug it into the equation. All right, your equation is A equals, here's our equation, right here. So A equals P times 1 plus R over N to the power of NT. So let's see, we're looking for A, so eventually we want everything to equal to A. Our principal is 4,000. Oh, no, not 400, 4,000. See, that was going to be an arithmetic mistake, and then, solve from there and you get a wrong answer, but we don't want that. 4,000, so always double check your work. 4,001 plus the rate is 0.054 all over N, which is 4. And now it's raised to N, which is 4, times T, which is 8. Alright, so if you can in your calculator, you can put it, of course you're going to use your calculator by hand. This would kind of be tedious to calculate. Alright, so we have 1 plus 0.054 over 4 to the power of 32. Alright, just make sure you plug it into your calculator correctly. It makes a difference. Calculators are kind of sensitive in that regard. Alright, and then finally, once you plug it all in, you should get A is equal to 6,143.56 when you round to the nearest tenths place, because money ends in the tenths place. Alright, it ends with the second decimal. And then this would be your final answer.